Hello guys, welcome to another amazing video. Now we are going to build a mini game on Maze Runner, or rather should I say that we are going to solve a level 3 problem asked in ZOHO using graphs and BFS. BFS is breadth first search.
Hello friends, Watashi no Namae code leveler. My video has been blocked in 2 territories because of the Maze Runner movie reference I had used here. And I had to alter the contents of the video and re-upload the video, so please support me my friends.
Okay guys, just forget what I just said until now and let's go to the coding.
Sorry.
Now let's create the maze class. Okay, first we are going to create a package and the package name is Maze Runner. Okay, now let's create a class which is my main class. Okay, now the name of the class is, I'm going to specify it as Maze Runner itself. Okay, now let's create a main function, public static void main of string okay. Now let's create a scanner method for the user input. Stem.in, fine, and now we want to import the scanner method. Okay, we have imported it. Now we are going to get the user input. So before starting guys, we are going to implement this in the form of graph. So I am going to use the matrix implementation of the graph. Okay, you are getting it right? Yes, I take it. Now we are getting the rows and columns. Out control plus enter the name, enter the number of rows. Okay, int yan is equal to sc dot next int function. Okay, now let's just copy this and paste here for the column. Yum columns. Okay, now let's check for the edge cases where the user can put an invalid input. So where n is less than or equal to 0 or m is less than or equal to 0, which means negative value, which will be obviously an invalid output. This out, control plus enter, which is an invalid. Now let's create a maze function, maze class, new maze function. Okay, so we are going to pass the arguments here, n and m. Okay, now let's create a class maze. Okay, now we are going to implement the methods in this maze class. Okay, now we are going to create the matrix, which is a character matrix. Now let's create a constructor to initialize the maze. Okay, public maze, public maze. We are going to pass arguments int row and int column. Okay, now we are going to create an instance for this maze. This dot maze, sorry, maze is equal to new char of row and column. Okay, and we are going to create the mazes, sorry, multiple maze dynamically, the row and column. Okay, now create the method for create function. Okay, now for of int I is equal to 0, I less than row, I plus plus, for of int j is equal to 0, j less than column, j plus plus, and once again we are going to initialize the array, sorry, matrix with values, which is the walkable path initially. So I am going to put w or 0 or o, anything. I take w 0. Okay, now we have created the matrix. Now let's print the maze. Public void print function. Okay, now I think the same time, I think just going to copy this. Yes, once again, no, so we are not using the row here because it is going to be initialized value length, or we can just use the arguments here, no problem. It's of 0 dot length function. Okay, now sys out done, and maze of I and j plus space. Okay, now let's see if this is implemented perfectly. Okay, we are going to create, sorry, I think print function print. We can create, use this. Yes, initialized matrix, initialized matrix. Okay, now let's run this. Now specifying the number of rows, number of columns. Oh, I just made a mistake here. Think Sys out. I didn't add a new line. \n. Okay, now it's perfect, I think. Ten. Oh, okay, where did I go wrong? That's 0, 0. So okay, \n, this is perfect. This one too, right? Let's check this later on the video. Okay. Alright everybody, let's introduce the components which we use here. The maze, the monster, the players, and the treasure. Okay.
I'm the map, I'm the map, I'm the map, I'm the map, I'm the map!
Now let's create the methods to add monsters and the treasure which we are going to use this code. So let's first call the methods maze dot place monsters, right? Think this goes perfect. Place treasure. Okay, now and again I'm going to print this. Okay, now let's print the matrix. The matrix after them placing. Okay. Maze dot print function, we are going to call it again. That's why I initialized it on that class. Now here comes the hard part. Now we are going to create a methods for adding the monsters and the treasures in this class. So now let's add this public void place monsters. Monsters function and I think we can use the random function for placing the monsters dynamically. So for dynamic allocation, random is equal to new random function, and now we are going to generate a random number of monsters to place in this matrix. So we need to know the minimum number of monsters to be placed, right? So going to use some mathematical implementations which can be altered based on your approach. Okay, now let's create it. Num monsters is equal to random dot next int. Okay, random dot next int of maze dot length function length into maze of 0 dot length by 3. I think it goes correct like this. And this is the values we are. This is the number of monsters we are going to add in this matrix. So this is the row multiplied by the column 1 by third. 1/3 of the matrix should occupy the monsters. Okay. So now let's print the number of monsters to be placed. To be placed. Okay. Now initially the number of monsters placed should be 0. Okay, right? Int mons placed is equal to 0. So I'm going to take this as live. Okay, now we are going to add the monsters in the matrix as required. Okay, so I am going to loop through the matrix randomly using random function. Monsters placed. Mons placed. Mons placed is less than number of monsters. This monsters. Okay. Are you getting it, guys? Monsters. Num monsters. And I'm going to create a random column and random row. Random row is equal to random dot next int function. Okay, now again int random call is equal to random dot next int function. Okay, now I think I missed something here. Okay, first let's finish this. If of maze of random row, okay, random column, random row or random call is equal to 0, that is the walkable path, or no, I think person so it should not be the entrance, right? Because the player is starting from the entrance. Okay, the player is starting from the entrance, which means the first column and the first row. So we are going to define a condition here with random row is equal to 0 and random call is equal to 0. Okay, now Again another condition we can place here, where the random row and the random column should satisfy, okay, where it should not be the exit, because the player has to escape through the exit, so there should not be monsters placed there. So I am going to add another condition, where random row is equal to maze dot length, okay, maze dot length, and random call is equal to maze dot maze of 0 dot length th minus 1. Okay, I think I defined all the conditions here. Okay, now what should I do now? Let's place the masters here. Maze of random row random call is equal to m. All right, okay, once again it's a character, okay, it's a character. Now we are going to increment the this value monsters placed, mons placed plus plus, and now we are placed all the monsters in this matrix. Another task left is to place the treasures. Public void place treasure of no, nothing should be here, and again we are going to call the random function here. Random is equal to new random function. Okay, now again we are going to use the random row and random column. Initialize it. Random row and random column. Okay, random row and random column. Now we are going to use a boolean value to check if we can place the treasure in a valid position, so that we are going to ensure that no monsters is around the treasure, so that the player can take the treasure easily and finish the game. Valid placement. Okay, now we are going to use a do while, because it is going to first place the value and check for it. Okay, random row is equal to, once again I think I'll use this. Okay, now what is the error here? I think this is a local variable. Okay, let's just change his name. Random call, random row, random call. What's in here? Why I'm getting the error here? Okay, let's finish this. No, it should not be causing me error. I think I will come to that part afterwards. And we are going to check for the valid placement. Valid placement is equal to is valid. We are going to call another method to check for the valid treasure position. Okay, for that we are going to use random row, comma, random column. Okay, now we are going to finish this while condition where while of not of valid position, valid placement, sorry, valid placement. Okay, now let's create a method to check for the valid position. Public boolean is valid treasure. Okay, I'm going to just copy this. Okay, valid position of int row comma int call. Okay, fine. Now let's see if the path is walkable to place the treasure row of call is equal to 0. That means no, should be checking for not equal to 0, so we should not use that place, so we are going to return false, and it again goes back it recursively. So now again what shall we do? We should also check for the entrance and exits. Row is equal to 0, ampersand call is equal to 0. Okay, now and once again we have covered the entrance. Now we are going to use the exit path. Row is equal to maze dot length. Okay, ampersand call is equal to maze of 0 dot length. Okay, now both the entrance and exit are covered, so we should return false. Alright, now we must place this at least at the half the size of the maze, okay, from the entrance. So we are going to implement minimum distance for placing the treasure, which is equal to maze dot length plus maze of 0 dot length, like we just used on the monsters. Okay, by 2 of the maze. Okay, now we are going to, okay, I just missed the semicolon, return the, what should I say, we are going to just return the minimum distance from the entrance to we are just checking with the absolute values. Okay, so I'm going to just use the math function, math dot absolute of row minus 0 plus math dot absolute of, no, not minimum distance, column minus 0. Okay, extra greater than or equal to minimum distance. Okay, which is from the entrance. Just finish this. I think this is correct. So we just placed the monsters and the treasures in the maze. Now why are we getting error here? Okay, I think I just made a mistake here. Oh right, I didn't mention here maze dot length for the row, maze of 0 dot length for the column. Now I should do the same here. Maze of 0 dot length. Okay, now okay, well, I am getting the error here because I initialized twice in here. Okay, that's the error here, duplication. Okay, right, now another errors, no more error here guys. So let me just run this again 110 and 10. Okay, the monsters are placed, just are placed. One second guys, I will just correct this part. Where did I go wrong? Backslash yarn, this is okay. Maze dot length, show My god. Treasure is also not placed, guys. Think I just made some error. Let's check the class methods once again. Is sure random, new random function, random column, random row. Okay, next int. So perfect. Random row, random column. So I found it, guys. Shit. I just made a silly mistake here. I didn't place the value t. That means the character. Sorry, guys. Random row and random call is equal to capital T for treasure. T for treasure. Okay. Now think this could work perfectly now. Okay. Now where's the problem is? Let's just finish the program first. Now comes the toughest part, where we should use BFS for finding the shortest path from the player to the treasure without fighting the monsters. Okay. Now
Tonight the music seems so loud. I wish that we
let's create a place for the player. Random is equal to new random function. Okay. Now just import the random class from the library. Okay. Now we are going to print call the shortest path function, shortest path of random dot next int. I will tell you why I am doing this. 0, because we are just going to start from the initial row and initial column, not other than that. This specifies the row and this specifies the column. Okay, like let me do this. 1 and again 2, once again 3. Now 1 comma 0, 2 comma 0 and 3 comma 0. Now we are going to use these values in the matrix, not other than that. Okay. Now let's create the method. Once again, now for finding the shortest path, we are going to create a graph. Okay, now that our first part. My god. Oh shit. Let's do this again. Private static class node. We are just going to initialize the node here. Okay. For this node, we are going to require the row, column, and the steps. Number of steps the player has moved, and the node previous, which I will explain while we move through the problem. Okay. now we are going to create a constructor node and int row, int column, int steps and node. Okay, now I'm going to instance it. This dot row is equal to row, this dot column is equal to col. Okay, and this dot steps is equal to steps. Now this dot previous is equal to previous. Okay, okay, now we are going to trace then mark the shortest path. Okay, we will come later to that. Part. So now I think okay, let's create the method to find the shortest path here. Public int shortest path, public int shortest path of int row, int col. Okay, shortest path. Okay, int row, row's length is equal to maze dot length, and int column length is equal to maze of 0 dot length. Okay, now we are going to create a Boolean matrix for visitor nodes. Visitor is equal to new Boolean of row length and column length, and we are going to create directions for the player to move. Okay, up, right, bottom, down. These are the 4 directions that the player could move, not diagonally. Sorry. He should be Spider-Man to do that, but he's just an ordinary player. First move forward and then backward and then down and then top. Okay, I just created this. Okay, front, back, down, top. I think I just do it in backward direction. Okay, leave it guys. This is going to be a BFS, so it should not be a problem as it goes through all the nodes. Okay, now node queue, new queue. We are going to queue class, linked list. Okay, now we are going to import the classes queue and then linked list. Okay, now I just imported it, and now initializing the first value of the player as true. We seated of row and column I think, which will be true for me as initially. And once again we are going to add values in the queue. Add of what should I add? Should add a new node. Okay, new node of row and column and steps are yes, steps which is 0. Initially we are going to increment dynamically. Okay, null, because it is going to point null initially the previous node. Okay, now going to implement the DFS. Oh, that a first part, I hate this, but it is easy to implement and it is fun to implement. Guys, I am using BFS, you can also use DFS. I think DFS is easy to implement, but I am going with the BFS so that it could give you a better understanding and foundation for this problem, and you can get a grasp of BFS easily. Okay, right. SMT error, corrected it. Node current is equal to q dot pull function, first removing the current value and going to check for the directions here. Okay, from the directions, right, directions colon direction. Okay, or I'm going to use the same name for this, directions. Okay, I will leave this as direction. Now the next row and next column we are going to get it. Next row is equal to the current row plus the direction. Okay, directions. I think I'm going to change here. Okay. Now int next call is equal to current dot call plus direction of 0. Okay, now we got both the next row and next column. Now we should just check for the boundary conditions, so we are going to use another method, boundary, in boundary of the next row and the next column. Okay, next column. Okay, afterwards we should just check for the visited nodes. That's where this visited comes to break my head and break my motivation. Next row and next column. Not visited. Okay, and another condition is there should be no monsters to scare away the players. Next row and next column. Okay, next row and next column should not be a monster. Okay, right, now all the conditions are specified. Now I think I should just now I should check if the current node is equal to the treasure. Okay, maze of next row, next column is equal to the treasure. Now we should just finish this BFS and print it. Shortest path. Shortest path. No, another name. Short maze path. I think we can use this name of current node. This current. Okay. Or otherwise, okay, let's just leave this, and we should just increment the method. Return current dot steps plus 1. Okay, this is for the number of steps we have reached. Alright, now after this case, if not satisfied, we are going to add it in the queue. Queue dot add of new node of next row and next column and current steps plus 1, and once again the current node which points to the previous node. Okay, now I think we should set the visited value of the matrix as to true. Next row and next column is equal to true. Initially all the boolean values of the matrices are false. Okay, now everything is covered, I think. So if no paths means that there is no way possible to reach the treasure, right? So return -1. Okay, now we should be able to trace the path. Okay, first I will just finish the boundary conditions. In boundary, private boolean in boundary of we are going to get the next row and next column value, int I and int j. Okay, int I and int j. So we should return if it is true or false. Okay, I should be greater than or equal to no I should be greater than or equal to 0 and I less than maze dot length. Okay, I less than maze dot length. Okay, it should be within this boundary. Okay, now for the column, j should be greater than or equal to 0, ampersand j should be less than maze of 0 dot length. Okay, now it should satisfy this in boundary condition, and now we should print the value of the player as we move around the matrix until we reach the treasure. Okay, now when we reach the treasure, this should call this method. Okay, after we reach this method, I should be creating a method to print the values of p in the matrix in order. Okay, I'm going to show you exactly that. Okay, let's chart it. Private void short, what the name I gave there, short path, short maze path. Okay, short maze path. Okay, node, we are just specified the node there. Node should be capital. Sorry guys, node node. So we just going to initialize this as temporary variable, or you can say current. Okay, used a temporary variable which is cur, and we are going to iterate it in the reverse direction. Okay, since we used previous for checking the values. Okay, now for the conditions, if of maze of car dot row of car dot column not is equal to t. Okay, t. Now why I am specifying the value t here? Any tingling in your brains, guys? Tell you in the comments if you know the reason why I used t here. Okay, right. Now I am going to mark the path. Maze of car dot row car dot column is equal to p. Okay, now the code is going to come to its end. We are going to iterate it backwards. Car is equal to car dot previous. Okay, now I am just going to call the print function. So south, let's press enter. Maze path is okay. Just finish this code. Now only problem is I just need to check why is this is not coming in a straight line in the form of matrix. For of int I is equal to 0, void create function I is equal to 0, I less than maze dot length, I plus plus. Okay. Oh shit, guys, found it. I made a silly mistake here. Not a silly mistake, I'm sorry. Okay, now I think we should not be getting an error anymore. Okay, let's run this. Number of rows 10, number of columns is 10. Ooh, shortest path, initialize matrix. Okay, the monsters is placed. Now this method is not being called. What's the error? Shortest path. Okay, let me check this. What's the problem? Think I should be getting no problem, but think I just made a mistake here. Okay. What's the mistake? Public in shortest path. Int roll n. Int.
It was at this moment he knew. He fucked up.
Guys, I found the mistake where I did it. Okay, sorry guys, I just made a small mistake here. Here. This is, I used 0 here, but it should be 1 because in this array, this index is 0 and this index is 1. I called both the indexes as 0, so, and this error, and my boundary condition is slightly wrong. I didn't call it perfectly in here, and I just corrected it. And the second mistake is here is I didn't mention p value here. Okay, now let's run this again. Let's do an application. Now specifying the row. Okay, once again. Wait. 10, and now we go there. So first just minus. Now the number of rows is 10 and the number of columns is 10 and the initialized matrix is zeros. Okay, now the number of monsters to be placed is 33 and only one treasure should be placed in here. Okay, that is this only one treasure. Okay, this matrix contains 33 monsters and the maze path is printed as here. The random player's path is specified here as 2 0 1 0. This is 1 0. Sorry guys. 3 0, and the treasure is placed at 2 3 8 5. 8 4. No, sorry, 8 5. This is 8 5, and this is 3 0 players. So we used BFS to find the shortest path here. Okay guys, thank you for watching this video. Let's meet again in another. I think I just missed the part which makes sense. Okay.
NANI? Oh my!
I just left to print the maximum steps used for this traversal. Okay, so I will be joining you soon in another video by solving this same problem by using DFS with the number of steps in it. Okay guys, I think this video will help you in the future, and if you like this video, like, share and subscribe to my YouTube channel for more videos. Thank you.